Hi there, the aim of this video is to add an impact effect to a bounce animation in Godot 3.1. The inspiration for this is Mario. No one bounces quite like Mario, so he makes a great case study. Mario's jump looks great for a lot of different reasons, but today we're looking at the dust particles when he lands. When Mario lands, he throws up dust particles around him. This helps add weight to his animation. We're going to try and emulate this in 2D, using what we've learnt using the animation player. First, let's make some notes about Mario's landing. Focusing on the dust, we can see the dust appears instantly when he lands. The dust also grows, slowly rises from the ground, then shrinks into nothing. There doesn't seem to be much randomness to it. All the dust particles appear at the same time. We're going to get as close to this as we can using good old-fashioned sprites, a little code, and the animation player. If you followed the last tutorial, you'll have a ball with a bounce animation. If not, you can download the source files from GitHub in the description below. You'll notice I've added the dust sprite we're going to animate. If you'd like to make your own, my sprite is 64 by 46 pixels. First, let's do some setup. If you try to click the run button in the top right, you might be shown this error. We need to choose the main scene in order for the game to run. Select the ball scene and click open. Our game runs and we can see the ball just chilling as balls do. Let's make it so the ball bounces when the game starts. Close the game and click on the ball node in the top left. Click on the attached script icon just above it. We're shown a dialog where we can choose the script template. For now, the defaults are fine, so click Create. We're shown an empty script with some helpful comments. At the top, we can see what the script extends from. This is usually the node type that the script is attached to. Here we have the ready function. This function is run when the node is created after all its children are ready. In our ball example, the ball's children are the sprite and the animation player. The ready function is where we want the ball to start bouncing. We need to tell the animation player to begin playing the bounce animation we made. Head into the ready function and type the following: $animation player. The $sign here is a convenient way to reference a node's child. Typing .play, open bracket, allows us to choose the bounce animation. Press enter and close the bracket. That's it! If we play the game now, the ball will start bouncing from the get-go. Now let's move on to creating the dust scene. Click the plus tab at the top of the panel to create a new scene. We're still in the script view, so click the 2D icon above. To make the root node, click on Custom Node and search for Position 2D. Now we've used Node 2D for our ball, but the Position 2D node is just a Node 2D that displays a cross in the editor. That makes it handy for moving it around and seeing where it is. I'm going to rename it Dust. Like our ball, we need a sprite and an animation player. I'll drag the dust image to the sprite's texture. Save the scene by pressing Ctrl S. Let's get to work. Create a new animation and call it Impact. As we noted before, the dust is instantly visible. It's small, grows quickly, then shrinks. Select the sprite, then go over to the Scale property. Set the scale at 0 seconds to 0.3 and click the keyframe icon. You'll be prompted to make a new track. Go for it. At 0.2 seconds, set the scale to 1. And finally, at the end of the animation, set the scale to 0. For the position, we noted that the dust is thrown outwards and rises slightly. At 0 seconds, let's offset the sprite a little. Set the position to 30 and -20 to the X and Y respectively. At 0.2 seconds, set the position to 120 -20. And finally, at the end of the animation, set the position to 170 and -45 to give a little bit of lift. Playing the animation back, we see the animation is a little flat. We need to add some easings. For the scale, the first two keys should have an out and in easing, respectively, to add that explosive feel. To add a drifty feel to the movement, make the first two key easings out. Play with the values until you're happy with them. Make sure to save the scene. It's now time to add the dust to the bounce animation. Head back to the ball scene and add a new call method track to the bounce animation. Choose the ball and click OK. Using this track, we can call a method found in the ball script. We're going to make a function that creates several dust scenes and fires off their animation. Let's go make that function. Click the script icon next to the ball node. This opens the ball script. This is going to sound a bit strange. Below the ready function, type func create dust impact, open close bracket, colon, enter. I told you. But this is where we're going to create the dust scenes. But first, we need to preload them. Head to the top of the script and type var dust underscore scene equals preload, open bracket, and use the arrow keys to select the dust scene. Then press enter and close the bracket. This loads a resource when the ball is created and stores it so we can keep using it. Head back down to the create dust impact function. We're going to create 4 dust scenes when this function is called. First, we need to instance the dust scene we loaded earlier. We do this by typing var dust equals dust underscore scene instance open close bracket. However, until the instance scene is added to the ball scene, we won't be able to see it. Add it to the scene by typing add underscore child open bracket dust close bracket. Now we have our function, we can call it in the animation player. Click on it and right click to add a key near the end of the animation. I chose about 1.9 seconds. Choose Create Dust Impact and click OK. Let's try running the game now. We can see the dust is created, but like the ball, we need the dust to play its animation when it's ready. Head back to the dust scene and add a script to the root node. As before, make the animation player play the impact animation in the ready function. Running the game again, we have a partial success. There are a few things to be mindful here though. For one, every time we call the create dust impact method, we are creating a new scene that is forever in our game. If left unchecked, it could cause performance issues, so we need to dispose of the scene when the animation is complete. We can do this by using signals. Click on the dust animation player. On the right, click on the Node tab. Here you can see a few things, but for now we're just interested in the signals. Double-click the animation finish signal. This screen allows us to choose which node will deal with the signal event. Choose the dust node and click connect. You can see it's taken us to the dust script and created a new function for us. This function will be called every time the animation from the animation player ends. To dispose of the scene, type q underscore free open close bracket. Q3 will remove the scene from the tree at the end of the current frame, so we don't have to worry about it. I'm going to print to the output to make sure this signal is activating correctly. Typing print open bracket, quote, animation finished, end quote, close bracket, that's a mouthful, will show us that this method is running. Let's try it now. We can see in the output that the function is indeed being called. If you don't see anything in the output, make sure the dust animation isn't set to loop, as looping animations technically never end. Great, now all that's left to do is add some more dust. Head back to the ball script. I'm going to instance 3 more dust scenes. For the first one, I'm going to instance it like I did before, but this time set the scale x to -1. This will reflect the dust in the y-axis. Let's see how that looks. Not bad, but the dust position is a little off. I'm going to create a new variable called dust position and set the vector 2 to 0, 40. Then I'll set each dust position to it. I'll add 2 more dust scenes, but this time reduce the scale to 0.5. making sure that the x value of one of them is negative so that it's reflected. Playing the scene again, we can see we got the desired effect. We've completed our aim, but this function is rather messy with duplicated code that we could tidy up a little. As an extension, I'd suggest looking at for loops in Godot and using one to condense this function and make it shorter. I've managed to get it down to about 9 lines of code. If you have any questions, let me know in the comments below and I'll get back to you. Otherwise, thanks for watching. Feel free to like or dislike the video and offer suggestions for similar tutorials in the comments below. Cheers!